Future Hacker. Life. Path. Future.
Welcome back, everybody. This is the second episode with Dr. Vidur Mahajan for Future Hacker. I'm your host, Maria Taiji. So on the last episode, we ended it discussing about the trend of having, at some point in the future, and I know that's already happening in some places, this integrated database so hospitals can actually be sharing information. So Vidur, we were also talking in our call, our prep for the interview, about how hard it is to get a good volume of imaging regarding some specific diseases that may be not so common. And then he told me how you can actually fake the diseases to be teaching the system about it. So how does it work exactly? How can you, fake a disease into an image so you can actually feed in the system and generate the intelligence? Is that something scalable?
So once again, thanks, Maria, for having me here. This is a super duper interesting aspect of deep learning and, machine learning that's emerging, which is, essentially called synthetic data generation. You actually see it every day in life also, like outside of medical imaging and healthcare and all of that, right? I'm sure many people here would have seen, this thing called de-oldify, which is a program that, you give it a black and white image and or a black and white photograph, and it makes it a color photograph, right? And it knows winter, it knows summer, you can, and then there are also algorithms out there that can, you give them a photograph of a rainy day and it can remove the rain from the photographs, and all sorts of image manipulation that you would expect from Photoshop, but it's all automated and it's all done by these deep learning algorithms. The same aspect is being applied to medical imaging. As you rightly said, there are always data sets that are difficult to get, both in terms of availability and also legality. So in that case, why not just get a machine to create more images like that? And the way that works is there are this generation of algorithms that are called GANs, generative adversarial networks, which basically you tell the system that, here are 5,000 examples of human faces. And the system learns what a human face looks like. And then you tell it that, okay, Mr. AI or Miss AI, produce one more human face. And it will create another human face. And that will be the face of a person who doesn't really exist. But it will have two eyes, it will have a ear, a nose, a mouth, and all those things, right? So, and I'm sure many of us would have seen photographs generated like this. Now you can actually take it one step further and say that, okay, this is a photograph of Vidur, and the photograph has his mouth open. Can you close his mouth? And, again, these same algorithms, they know, know is a strong word, but they can create an image with his mouth closed from an image of his mouth open. So, and I'm sure, we've all seen those videos, right? The funny ones called deep fakes, where, you have these people, it's generally done with politicians. You have these people, saying stuff when it's a fake video. They're not saying those things, but using AI, you can generate those kind of videos. So when you apply that same technique and that same technology to medical imaging is when you can generate synthetic data. So you can literally say that, okay, I have only 10 images of a type of abnormality on, say, an X-ray, but now I need, 1,000 images that have a similar kind of abnormality. There are techniques available today which can do a reasonably good job. I won't say that they're 100% there, but there's a paper that came out just a few weeks ago from a company called Chiron Medical in UK, where they generated extremely high resolution mammography images, tests done to search for breast cancer, and they generated extremely high resolution mammography images that were not real images. So the idea is that you train an AI system to be able to generate an image of a certain type that it knows what it looks like. Now, there are interesting security implications of this as well, right? One, what I talked till now was, just you're unable to get that data because you want to make an AI algorithm, so you create that data instead. The more interesting yet potentially dangerous application is when you take a normal image and you put a disease in it. Right. So you do my CT scan and I don't actually have lung cancer, but you use AI to put lung cancer in my images, and the radiologist, the person who's reading the scan, they have no idea that the lung cancer doesn't actually exist, or the other way around, right? You take an X-ray, the X-ray has some disease, but you use these AI techniques to remove that disease instantaneously from that X-ray. It still remains the same person's X-ray. Like if you're wearing jewelry, or if your shirt buttons are visible, any of those things, they would still be visible. It's just the disease that disappears. So extremely cutting edge, but very quickly coming into the mainstream, are these techniques. So everyone who's working on this stuff should be aware of these techniques. And I just find it really, really fascinating.
It is. I completely agree with you. And, thinking about that when you commented about, how it's being used today for fun, for politics, with the advancements on that, I wonder this is going to take fake news to an entirely new level, right? So there's the good side of the medical application and everything else of what the technology can do to apply, but the evil use as well is something that everybody must be aware of, right?
Oh, absolutely. And, not just fake news, right, Maria? You think of it, it could be fake entertainment, right? Like literally, I could be seeing a movie with anyone I know playing the role of James Bond, right? Or something like that. So it's just fascinating. And, Mark Zuckerberg talks about this a lot because, he's invested in like Facebook owns one of the biggest augmented reality companies out there. And they actually talk about this vision where everything is AI generated. So I don't know, good, bad, that the jury's out there, but it's a world that's coming. For sure.
Yeah, that's for sure. So, Dr. Vidur, the big question that I usually ask for any innovation there, how to democratize it? I like something that you told me. You said developing countries need the help of AI for imaging diagnosis because they do not have doctors. And developed countries, on the other side, they need it to cut costs. But is it even affordable to a developing country?
Affordable, Maria, is a relative term, right? Affordable is related to the value that a software or a product or a algorithm has. And in AI's context, if we think of AI in this very narrow domain of, say, cognitive AI, right, where you are essentially replicating the work that a doctor does, it's certainly valuable. Or it's certainly affordable because you are allowing a doctor to diagnose or treat a much higher number of patients than what they do otherwise. The interesting aspect is, and the way I like to think about this is, doctors' salaries vary very much across the world. I think physicians in the US may make like 10 to 20 times more money than physicians in India, for example. Because of that, if an algorithm helps a doctor in India, it might mean more revenue for the doctor in India. But if an algorithm helps someone in the US, it might mean more efficiency for the doctor in the US. So it's a very interesting, delicate play. But the cool thing about software is that once you've built it out, the variable cost of deploying it is near zero, right? It's most of the cost is development and then a little bit of cost for maintenance. So as we see, something like Zoom, right? It has the same price across the world, or something like Slack, or any of these softwares. So they will certainly find their market sweet spots in terms of pricing. But to answer your question, is it affordable? Certainly yes. And if it's not affordable, then those companies won't actually make a market out of it. in the developing world. So yeah, but as long as you're making a doctor more either better, faster, or more efficient, there will certainly be the affordability element there.
Yeah, it makes a lot of sense to me. So I'm going to change the subject a lot, but before doing that, I'd like to know your take regarding, it's future hackers. So, you're always going to be asking about the future, like in maybe 20, 30 years from now. When we're talking about this whole integration of data and the communication between hospitals, something that is, fairly common, at least to travelers, is when you are abroad, if you run into an accident, if anything happened to you, you're very vulnerable, right? Maybe you can't communicate your medical history. It's hard for the hospitals to understand whatever is going on. Do you think that in the future we'll somehow be able to have our data inputted in ourselves? Maybe we could just get scanned and immediately people will have access to whatever is going on. Or do you think that, it's going to take really long and we will have to keep relying on regular communications and access to database and access to people histories and calling the family or whatever people have to do today to figure things out?
I think, Maria, at a 20-30 year time span, it's highly likely that you could Google, Vidur Mahajan history, and you'll probably see everything that I've ever had. So, given the way things are, and it would have all been put up there voluntarily by me. And, it sounds like an absolute crazy idea, but if you think of it, and, since this is super future hacker, I am, trying to be a little extra futuristic. But if you go back 15 years and somebody told you that, hey, Maria, one day people are going to be uploading photographs of themselves for the entire world to see for free and for no reason whatsoever, right? You would have thought the person's crazy, right? And today, like Instagram, Facebook, Twitter, whatnot, like people are just sharing everything about them, including their illnesses. You look at the photographs of people getting vaccinated and all that. So I really think in a 30-year time span, there would be some way for us to communicate our medical history, no matter where we are in the world. And you are right, it would be somehow linked to the person. But I don't think it will be an implantable chip. I just think that's too much effort for too little gain. Like, why would you need that? Like, you could, I don't know, you could just maybe scan a barcode or look at my phone or something like that. But certainly it would be a reality, and it would be, there for all to kind of see.
I loved when you said that you were being extra futurist. So, as promised, let's change the subject. So you're also running a genomics lab for both preventive medicine, in which you identify if the person is prone to having a disease, and precision medicine, having found the disease, which should be the best treatment. So tell us about this full 360 view project that you're working on.
Yeah, so thanks for bringing that up, Maria. It's again one of those highly futuristic, crazy kind of things that we're doing. The idea is in our 360-degree project, how we've called it, is that if a patient or if a person comes to me and says, hey, Vidur, you run these fancy labs, you have these fancy radiology equipment. Can you tell me if I have cancer right now? And can you tell me when I will get cancer, right? Just as an example. I would need to, number one, see that person's inherited risk of getting cancer, right? So what is the risk of getting cancer that person has in his or her genes? That is done through, this thing called genome sequencing, where we literally look at the DNA in your body and try to match it against a database of known cancer-causing mutations or mutations that put you at risk of having cancer. The other thing we would do is we would do a whole body MRI to try to figure out whether or not you have cancer at that moment. Now, the interesting thing is that for the genomics side, we have this amazing project called the Human Genome Project, which told us what the normal human genome should look like. And then all of us are essentially variants of that genome, right? So if I have brown eyes, I'll have some mutation that causes those brown eyes, so I have reference to go by to figure out how I am different. On the whole body MRI side, there is no such reference, right? I do not know what a normal 40-year-old female from North India should look like, right, on a MRI. So what we are trying to do is build a database of whole body MRI scans of as many people as we can. We think of it as our own little human phenome project, where, a phenome is essentially, the manifestation of the genome. So, it's like what we look like, how we behave, all of those things. So the idea is to put together a database of normal, again within quotes, people in different age groups and gender groups, and then try to figure out what the normal 30 to 40-year-old, male should look like. And then when I do a patient's scan, or I do a person's scan to figure out whether there's anything wrong with them or not, I have a reference to go back to. And then as I keep doing these scans, my database keeps getting built. So this is what we're trying to do, and we're correlating it all against genomics data, and trying to see if we can predict one from the other. It's fairly far out there, but yeah, we're trying.
That's pretty awesome. And I hope you can somehow keep us updated, if you have anything new to share. I'm sure that you're going to. So, we have been covering in our podcasts about the fight against aging, which has everything to do with, preventive medicine and how gene editing could avoid some diseases to happen in the first place. That's a very controversial topic. It was actually the very, very first international interview for Future Hacker. It was about this topic with Dr. Aubrey de Grey. I'd love to get your take on that.
Have you seen this movie called Gattaca? It talks about two types of people in the world. There are, babies who are born out of love, the regular way people make babies, and babies who are born in the lab. Right. And the babies who are born in the lab, like, the parents can choose everything, like what level of intelligence you want, what kind of musculature and this and that. And, it's essentially, and it talks about this journey of, two brothers. They essentially show how a regular person, or like a normal born baby, is able to match up to the genetically engineered people. And that movie, and this is going to be super controversial, but that movie showed that maybe it's okay to do gene editing for everyone, right? Only if everyone gets access to it. Now, that's a very, very difficult thing to do. But if we are able to extend human lifespan, both in terms of time and quality, without causing harm to anyone else, then why not? Right? Because if I'm not causing harm to anyone else, but I'm doing good for me, then is there anything wrong in it?
But I have a question for you. Do you have this thought, no matter the reason? Or I'll give you some examples. So one thing is to go into gene editing for diseases or disabilities or medical conditions. And there's also, for sure, is going to open a path for gene editing for, having specific eye color, hair color, or, being slim or whatever, Let's say for more, not so important reasons. Yes, I'm taking care of the words I'm using, but, this is unavoidable, right? So your thought is, as long as it's not harming anyone, right, you don't see as an issue. But let's talk about racial issues. Do you think this would be a way of segregating people more if it's going to be a choice? Or you're just thinking too much about it,
Oh, absolutely. Absolutely, yes. Basically, you're right? So if one group of people becomes much, much more superior to another group of people, then certainly, yes, it is obviously wrong. Like, there is no denying that. But then the thing is, the cool, and you alluded to democratization earlier during our conversation. The thing is, 10 years ago, having a smartphone was a privilege, right? And 10 years ago, you could watch YouTube, you had WhatsApp, you could pretty much do everything that you can do on a phone today. Maybe pictures weren't as nice, maybe data wasn't as fast, but if you had a smartphone 10 years ago and if you have a smartphone today, you are not really doing different things, right? So I asked myself this question once. I was like, in 2007, I had an iPod Touch and I could do everything on it that I can do on a phone today. But so what's the difference, right? Have we made no progress in 13 years? No. Today, everybody has a smartphone, right? So similarly with, things like gene editing and also brain-computer interfaces, right? Elon Musk is working on Neuralink, which might just make gene editing redundant. But I think you have to start somewhere, and as the, I hate to say it, but as the business model builds, democratization happens. So yeah, and it's the same, right? Like you have people spend thousands of dollars on eyeliner and makeup and things like that. Is that different from editing your genes to get blue eyes? I really don't know. But yes, it has to be regulated to a great extent. It has to ensure equity, fairness, and all those things. But difficult to monitor. Should we not push for it? I really don't know.
Yeah, definitely a good discussion, right? At least, at the very least.
Oh yeah, obviously. And we could talk for one more episode on just this. But
Exactly. Dr. Vidur, it was so great to have you with us. Unfortunately, we're out of time. So I'm going to leave the last word for you if you have any final comments. And as you said, there's so much to discuss in this field that we could do several other episodes. If you have any breakthrough in your company, feel free to knock our door. The doors are open here. So, any final words? It was just a pleasure to have you on the show. Thank you so much.
Thank you so much, Maria. And I'll close with this quote from Jack Welch, who was the legendary CEO of GE. I think it applies to most things related to the future, especially innovation and all, where he says change before you have to, right? And I think in healthcare that is more relevant than ever before, right? And I think COVID has taught us so much. So to everybody out there, number one, think about working in healthcare. We need a lot. We have a lot of smart people working in healthcare, but the smartest people on the planet are figuring out how to sell ads. So, maybe if the smartest people on the planet helping figure out healthcare, we would be much more ahead in things. And if you are a healthcare provider, if you're listening to this, think about change. Otherwise, you'll be forced to change, as Jack Welch said. So thank you so much, Maria, for doing this. It's truly a pleasure, honor, and we'll stay in touch.
Awesome. Thanks.
Future Hacker. Life. Path. Future.